Go.
Thank you for the introduction. I'm Jeremy. I'm the founder of Passlink. That came out of this late night blog post, which you've heard. I'm going to go through a little background of the blog post, which is not a method you should use, and for reasons which we'll talk about. And then we'll get into some methods which hopefully you would think of using, and go from there. But clearly we live in a world that is a very unlevel playing field, and I'm learning more and more how unlevel this playing field actually is today. $20,000, 25 no GPU crackers. This is a very unlevel playing field. Humans choose terrible passwords, low entropy. They reuse them everywhere, and we know they defeat these password policies. I hate password policies, and you guys are crazy good at attacking these hashes. You also sort of have to assume if you're running a web service that your hashes have pretty much already been stolen. And so if you're starting a site and you want to do the right thing, which is sort of how I got into this, and you want to be as secure as possible, aside from the sort of theology of, oh, just use scrypt, just use bcrypt, what do? How do you hash slow enough to protect these ridiculously weak passwords? If it's the top 10,000 passwords, and 50% of your users are using top 10,000 passwords, you can't hash slow enough. How do you make the password stronger without making the user want to log out, right, and never come back? And how do you keep the hashes safe in the first place? To me, it seems like if you can't do number 3, number 1 and 2 are sort of just like you're hanging on threads. So the initial blog post was a better way to store password hashes, question mark. I put this out in July, and very quickly on Reddit, somebody dubbed this security through obesity, if you've heard of that. Typically, the current practice is you'll have a user table, and you'll either have a salt column and a hash column, or a column with the salt and hash in. And there's a one-to-one relationship between the salt, the hash, and the user. So my concept was, well, why do we need this? What if we stored the hashes separately with no foreign key pointing back to a specific user? And then, well, we have this list of hashes. That's all it is. List of 32-byte values, for example. What if we just made the list arbitrarily large by just throwing random data into it? Pick a number. 100 terabytes sound good? And what if we just validate passwords by checking if the hash exists in the data set? And the really funny thing is, the chance of collisions, even after you store 10 to the 68 hashes in this list, you're still at, this is for 512, SHA-512, you're still at 10 to the negative 18th chance of having a collision. So the biggest complaint that was on Reddit and Hacker News was, oh, collisions. Well, collisions isn't the problem, but they're a problem. I'll walk through it just in case it's not obvious. Users table, you have your name, a salt. You do the HMAC of the salt and the pass. You throw it into the hashes table. Okay, we talked about it. Well, there's an attack vector here, and this was really interesting that somebody pointed out within about 4 hours of the blog going up. So let's assume that the attacker has access to users in the hashes table. So now this is interesting. This was a person saying, well, there's an attack vector, but in order for it to work, you have to have access to the table. Okay, fine. If you know the salt, if you compute an HMAC of that salt and some backdoor password that you want to be able to use to get to that account, maybe after you are kicked out of the building for hacking the password, hacking the database, sneak it into the hashes table, now you have 2 passwords that work, okay, for the same user. And no way to audit it. Because remember, we've stuffed this hashes table so full of random data, there's you might have a million users and 100 billion rows in the table. Okay, so how would we protect against this? Kind of interesting. So now you have a salt one, you do the HMAC, you get an H1. You find the H1 in the table, and there's a corresponding salt 2 that's just in a random number. So instead of having one column stuffed with random data, you'll have 2 columns stuffed with random data, and then every once in a while there'll be a valid row that has an H1 that actually matters. Take that salt 2, do another HMAC with salt 2 in the password, and compare it to your hash 2. What does this do? So in order to get the secret backdoor password, you would have to do a pre-image attack, if I skip to the good part. So, okay, we're not worried about the secret backdoor password. This is kind of interesting, but it's not quite good enough. And a few things that I didn't like about it is, okay, the database is going to grow over time. It's going to slow over time. There's possibly timing attacks if you're looking for a row in the table that exists versus a row in the table that doesn't exist. There's also this sort of information disclosure thing. We really want this hashes table to have no valid info in it, that if it were to get stolen, you lose nothing. But the machine sort of knows too much, because when it finds if you give it a hash and it tries to look it up and it's there, it knows, oh, that was a valid hash. Solar also sort of dug into it at his talk a couple weeks ago. He has his slides up. I should have put the link, I'm sorry. He was looking at things like, can you look at what the database is doing and maybe look at statistics that it's keeping or that the operating system might be keeping on what parts of the database are being used. And then he also said, well, it's not going to slow cracking these passwords down because we can compress it. We'll just take maybe the first 24 bits of each hash, throw it through a Bloom filter, and if we have a gigabyte of RAM available, we can know when we're doing our dictionary tags if the hash was in the table or not, without having to try to actually deal with this 100 terabyte table. So, okay, well, I'm still stuck on this idea, and I'm still thinking about it a lot. And so, okay, what about a data pool? What about if you had a large random, effectively a byte array? Let's think about it like that. Okay, you call a function getSalt with the hash. Use the hash as an index into the byte array. So hash modulo byte array, and pull whatever 32 bytes, pull it out. Use that as a salt. Okay, so the good thing about this is the data pool, it doesn't grow or shrink as new users are added. It can be a fixed size, that's great. It's a constant lookup speed. And also, whatever process is dealing with this data pool, when it's given a hash value, it has no clue whether that hash was a valid password or an invalid password. So this can be there's no data disclosure, there's no information leak if you have this data pool and you're running it as a separate machine. So not everyone's going to want to stick 100 terabytes up on their network somewhere. What if you do blind hashing as a service? So here's the concept. Site stores user logs in. They give the site their user and their password. The site says, okay, pull salt1 from their database. And they have hash2 in their database. Right? Salt1 and hash2 have nothing to do with each other. If you steal the site's database and you see a salt and a hash, you go to crack it, you're going to get nowhere, because your HMAC to get that hash was not done with that salt. They're going to call out. They're going to give the hash out to the data store, whoever's providing the data store. The data store is going to give back a salt, and we'll do that. We can do the HMAC and the verification. So I went out. I showed this deck to some people in the valley, and got a little bit of money and spent a little time on this, and we built a service. And that's what TopLink is. And so it's evolved a little bit. First thing is we want to isolate one site from another if we're providing this service, this 100 terabyte data pool on a very large number of SSDs.
How's that right?
We give each site an app ID. It's just a random 32 byte value. The site can then do things like whitelist on their app ID. So they'll say, well, my server is at this IP or at these IPs. And so if somebody's going to connect to you and ask for a salt with this app ID, it better be these IPs. We're going to HMAC whatever comes, that hash that they give us with their app ID. So that they don't really have control over what we use as the index. And then we'll HMAC again on the way out so that the data that they see is not actually the data in the data pool. And that prevents any kind of siphoning. We want to increase the data pool usage. So there's basically, if you only look up once into the data pool, then let's say an attacker was able to steal 50% of your data pool and they were trying to run a dictionary against it, 50% of their attempts would actually be able to resolve into they'd actually be able to check. And 50% of them, you wouldn't have the data to even compute the hash. But if you look up multiple times, it goes down exponentially. So if you do, for example, 20 lookups, you need 99%, or that's not exact, I'm pulling that number out of thin air. If you say look up 20 times, you'll need a very large percentage of the data pool just to even calculate hashes for your dictionary, for your word list. We're going to release a whole bunch of plugins and libraries for applications like Drupal, Joomla, WordPress, and some top languages. And so what I hope that this ends up becoming is a little bit of a paradigm shift. Instead of being able to say, steal one record in a user's table and get enough data to be able to start a targeted attack against a high-value target, you're now going to need that row plus the majority of an arbitrarily large data pool, depending on how motivated that site is, that service is to protect their hashes. We're going to be going online in the next couple weeks. I'd be very, very interested to hear all of your feedback. If you're interested in beta testing it, if you're interested in getting an app ID and playing with it, if you're interested in DDoSing it, seriously, do it. We want it because we want this thing to be solid. Send me an email and questions.
I really love the idea. I really like going with not storing passwords, but storing if you know the password, sort of, which is kind of what I get next. But if there was in your country a agency that might get a copy of that data pool,
this is what's really cool about the data pool.
Would they be in a different position?
The data pool has no value except that the site is now back to where they started. If you lose the data pool, now all you have to do is steal the site's database, and you're good to go.
Mm-hmm.
But the data pool on its own gives you nothing. So
what is the site's database on it?
and then the site, if they get hacked, they've lost nothing, unless I also lose their data pool. So I get to be in the good
position. If you
position.
happen to be an agency in your country of operation that might get a copy of that database that you wouldn't be allowed to tell us about,
Yeah.
then that agency would be
They'd still need this data. And this is why I call it blind hashing, and maybe I need to get a better name, but the worst case scenario is that you're no better off than you were before.
Right.
And by the way, it's fully compatible with if the site wants to do scrypt, bcrypt, whatever they want to do before they hand the hash over, they can do it. And I would encourage it. As much resources as they have to do as, key strengthening on their side, we're going to try to return, for every request that comes in, we want to return a response as quickly as possible, add as little latency as possible. We're going to be doing things like, setting up clusters and data centers so that people can have like long-term open SSL connections so that there's no latency for setting up and pipelining requests and all that. So the service Tapling's job at this point becomes having a very large data set, lots of SSDs, high availability, fault tolerant, multiple data centers, geographically distributed.
So, as time goes by, you'll need to make the data pool bigger.
Yes. So there's some of the things that are going to go into the client libraries are, well, there's a startup. There's a question on what do you do when the user first says, oh, I want to start using this. You can take the hashes that are in the database as inputs and just extend it right away and upgrade all their hashes on day one. Or you can just do it as people log in and make it a little bit cleaner. You can also, when somebody logs in, if you increase, double the size of the data pool, you do a two-step process to basically validate and then upgrade. So basically for each app ID, we'll be tracking how big the data pool was when that app ID was created. And then over time, if they opt to sit, I'm figuring that people will be interested in doubling, so 100 terabytes to 200 to 400 to petabyte or to whatever.
Do you have a business model in mind in terms of pricing? Because it sounds like something that might be hard to opt out of.
So getting in and getting out needs to be easy. And so, because I fully believe that if someone's going to try using this, they have to be able to get out. So in order to get into it, you can either do the upgrade hashing, or you can say just new users. We're also going to have a system where you can just put a mask in and say, oh, I just want to do, this is code that the site would put in. They could say, oh, I only want to do users that start with A. They can opt into it as slowly as they want. And then to opt out of it, when the user logs in, you can just
do you
pull them out.
Do you have an idea of a business model and sort of?
Yeah, we want to sell it as like software as a service, platform as a service.
Do you have any idea at this point on what kind of pricing you'll? Or are you just going to try it out and see what it looks?
Yeah, we have some pricing. I don't want to announce any sort of pricing at this point. It's going to depend on. I think pricing depends on how big the data pool is, where you want your data center to be. So, for example, someone who wants to connect to a data center in the U.S. might pay less than somebody who wants to connect to a data center that's in a more costly, you know,
London.
right. You know, because you're going to want to connect, you're going to want this storage to be pretty darn close, if not co-located in the same data center as you, to keep the latency down. Because any network latency is lost time. It's not adding any value like iterating the hash would.
Worst case scenario is like not your data to be exposed online, but actually you completely lose the connectivity or whatever.
Yes.
Then the clients cannot connect.
That's right. You can't log in if the site, if TapLink goes down. So you know, if the service goes down, just like if you were using any other third-party authentication, yeah, if they go down, and they, you know, Facebook has gone down in the past.
Oh, yeah.
Then,
Oh, yeah.
then yeah, you'd be dead in the water. So the trust level that the site would have to have in the service is equivalent. But the good thing is, there's absolutely no impact on the user experience, and that to me is extremely important because users do not care. They want to see the brand of the site that they're logging into. They want to see it completely owned by that site. They don't want to care that something's happening in the back end. And we're not going to know anything about the users and anything about their passwords. We don't even know if, when we get a hash, if it's a valid password. You know, that could be an invalid request that just came in. We have no idea how many users are even logged. I mean, you could start looking into timing attacks and stuff like that. Or like logging on this computer and watch the traffic. That's probably a small.
Do you have cards?
Yes.
Okay. I think a lot of us would like to try this.
Yeah, and I'm looking for, so like I said, we've got some funding. We're kickstarting this. We're looking for people who have certain skill sets that could potentially help or are interested in helping.
How are you seeding the data?
Okay, so to create the data pool, you need a whole lot of entropy, right? So what's weird is if you ask,
They have a feed from NSA, so
yeah, well, if you ask like DevRandom for data, it doesn't ever stop giving it to you, but you have to assume that it's run out of entropy at some point.
DevRandom usually blocks WRandom mode.
Okay. So, you know, there's that. And then the other thing I was thinking of was encrypting whatever the DevRandom gives you with a key and then forgetting the key. Running it through stream ciphers and then forgetting the ciphers. Obviously, the data itself, like the whole concept of protecting this data at rest, generating it to make sure it's random and then protecting it at rest is the whole business. You fail at that, and then you've got no customers. So,
What kind of redundancy are you?
So you're gonna need like triplicate tape backup stored in Iron Mountain kind of thing. You're gonna need, so they'll be offline because you can never lose the data pool. It's one thing to go down for 60 seconds. It's another thing to actually have corruption in the data pool. We're also looking at things like if the file system if there's corruption in the disk, how you detect it, because you're seeking through these. There's a lot of things to think about. That's the IP actually. So the question, the answer of how to is, well, some of the answer is we don't know yet. Some of the answers we've thought a lot about. We thought about things like kernel level modifications, file system level modifications that we can make to make it so that even in our code we don't even know what the data pool is. We don't want that data to move. We want that data to stay as close to its encrypted form on the SSD as possible.
I recall there was a recent Hacker News thread on random memory corruption with MongoDB, and that was not 100 terabytes.
Yeah.
I was just
So
asked about MongoDB.
The really good thing about this is there's no database involved. There's not going to be a database layer.
No, but I mean, if you've got memory errors, you have.
Yeah.
Yeah.
So ECC RAM, parity in the data pool, maybe file systems that have parity built in. There are some parities of file systems that are out there. Scanning the data constantly, there's lots of things you can think about to just make sure that the data pool is intact. The good thing is that like bit flips on a drive at rest is pretty low probability.
At some point, you just have to pay somebody to swap drives.
Yeah, you assume that the good thing is it's write once and read forever.
I was just gonna say SSDs don't really suffer from reads.
There's not really a read endurance problem. Solar actually,
Getting together 100 terabytes of
It's not that hard.
it's not that hard actually. The 512 gig SSDs have come down a lot in price. It's real. I mean, so, potentially even launching, you don't need a whole lot of funding to launch with 100 terabytes. You can launch with a lot
That's
more.
only 200 drives.
Yeah.
So.
And I mean, but then now you want that in X number of data centers, and you want redundancy within the rack, and you want redundancy across data centers.
Less than half of the chance of one of the
So,
faulty, right?
pretty quickly, you're probably buying, thousands of SSDs, but really that's a minor cost if you're thinking about actually protecting the world of passwords.
So have you thought about synchronizing terabyte? Are you running with copies or are you doing it over the internet?
So,
I don't understand.
so the question is now, I've been running for the double the time that you actually spent doing your presentation. So, you will still be around, I guess?
Yeah, I'm not going anywhere.
Yeah, so Jeremy is here, but I would just say thank you.
Thanks very much.